Hello everyone, we are Team 23, and the members of our group are Maureen Thomas, Chandler Gay, Irvi Femini, Megan Zabinski, and Gustavo Tovar, and we will be presenting our analysis and redesign of our smoothie maker. So first is the product description. Our product is a blender for smoothie makers, and this features a 500-watt motor and a power supply of 220 voltages with a 1.5 liter capacity with this plastic container, and it only has a weight of 2.4 kilograms. Some key features about the blender are its blade and goblet are from stainless steel, and it features a tab to facilitate content distribution from the container. And for the product safety, it also has non-slip feet to prevent potential spills. Here we have the CAD model. On the left side, you have the overall assembled product, and on the right side, we have an exploded view with the layout of all the components included in its overall position within the sequence, with the power supply and motor inside the main body. Primary and secondary customers. For primary customers, that would include people who need a product to make smoothies, but more so a machine that can blend both solids and liquids, with the blade mechanism to produce a fine texture and consistency to achieve the desired quality of smoothies. For the product specifications and possible areas of improvements to improve the overall product for customer use.
With the aforementioned product description and primary and secondary customers, our team created a fast diagram to illustrate our chosen product's functional analysis. The smoothie maker that we're focusing on has a main function of combining ingredients. It also has a few key functions that offshoot from this, which include cut contents, mixed contents, and store contents.
And for the next part, we'll be looking over assembly sequence analysis, where we will determine which would be the best way to assemble. And the first one we're doing is top down, where we have the container as the main assembly. And as you can see, we have 3 different assembly points with the blades, the tap, as well as the main body base. For the second one, with bottom up, with the main body being the main assembly point, you can tell there's quite a few main differences with the container itself, containing multiple sub-assemblies with the base and the tap, and there's multiple smaller components with like the rubber feet, the buttons, and the main body connection. Because for the main body one, there's only one main sub-assembly, we think that will make it easier to assemble and not having to worry about different components, and overall just easier to manufacture. And that's why looking at the criterion, that will be the best method.
Thank you. Moving on to the function component mapping matrix, we can see that there are 5 top subassemblies for the smoothie maker, and each component serves 1 to 2 functions. So as you can see, the lid serves the function of containing the contents, the blades are cutting and mixing the contents, the tap is assisting pour, and the main body, including the motor and power supply, are aiding the process of cutting and mixing contents. Finally, we have the container itself that is containing the contents. Next, we have the bill of materials and rough cost analysis.
To guide our bill of material creation and rough cost analysis, our team first assumed that the production rate for blenders is around 25 million units per year. Additionally, we estimated that the labor rate used to calculate the assembly cost was around $17 per hour. For certain processes such as laser cutting, die casting, and compression molding, our team found data on typical pricing for use and purchase to guide our calculations, as illustrated on the slide.
Here you can see our full bill of materials and rough cost estimate. It contains the breakdown of each cost, including the material cost, which is based on the estimated volume of the piece, the processing cost, which is based on the cost of running the machine or process for a period of time, the assembly cost, which was used from the assumption of the mechanical assembler wages, and a tooling cost per part if the process needed it. Overall, the most expensive part is purchased, which is the power supply that connects to the motor, and the total estimated cost per assembly is around $30.
For the product family design, we note the functional differences, with the important functions of the overall product remaining the same, such as the variation in blending speed, the detachable container, and its ability to blend liquids and solid contents to define consistency, and with the key differences being the interchangeable blade attachment and a high power motor. So for component commonality, we note that for most of the platforms of the overall product are the same, with the key changes being in the addition of the handlebar, removal of the dispensary tab, change to the blades, and the implementation of a one solid rubber foot.
With all that in mind, let's look at the original design again. Note that it has no way of lifting or holding the container easily, the amount of rubber feet it has at the exploded blade assembly. The blade assembly itself has a lot of components, mostly consisting of several rings and spacers. Taking a look at our redesign, in order to appease both primary and secondary customers, we have provided both simplified usage by removing the tap assembly but adding a handle for easier lifting and moving for the container, allowing for more efficient pouring. The number of feet has been reduced to one component, which could be attached in the same way as the old feet, but only requiring one step. And finally, a simplification of the blade assembly, combining the spacers and rings into one component, removing 4 total components from the whole assembly, making it easier to assemble, clean, and or replace. The added benefit is that because the rings have combined into one part, rubber can be fully allocated into making the feet, decreasing the total amount of molds needed for the previously needed rubber components being injection molded. Thank you for your time. This has been our group's analysis and redesign of a smoothie maker.